Hello. This video is going to talk a little bit about solving some basic equations. This is our math analysis class, and this is in section 8 of that prerequisite chapter. Again, if you are struggling with some of these topics, please make sure to spend some extra time working on some extra problems, looking at the other videos that are found out in WebAssign. And if you need help, please email me so that we can get some of these things, these foggy brains cleared out a little bit. Okay, so here are some examples. Some of these will be relatively easy, at least they should be. Some of these will build a little bit and be kind of bring back some topics or some things that we haven't seen for a while. All right, so solving an equation. First of all, there's a difference between an expression and an equation. And so when we are talking about expressions, there's things we can do. And when we talk about equations, we have actually, I think, more options because we can make things look nicer. When we have expressions, when we have a fraction, we can't undo a fraction. Can't get rid of that fraction idea. When we have equations, we can. So, and we'll see that in an example shortly. So first of all, in this section, we're just going to be talking about linear equations, which means we have just single x's or single y's or single variables. They're not squared, they're not cubed, there's no square roots. We'll see those later as we build through the semester. But we need to be able to solve something like this. And I know some of you are really good at it, and how many pieces or steps you write down, that's up to you. Our process is to get the x's all on one side, the constants all on the other, and then to finally solve for that x. So what I'm going to do, and I'm not going to write down all of my little steps, but I will talk through them, is my first step is I'm going to add 4 to both sides. So I'm going to add 4 to this, which will get rid of that minus 4. And adding 4 to this side is going to be adding to that 8 to make it a 12. My next step is to move that x to the other side so that they're all on one side, and I'm going to move this 3x by subtracting 3x from both sides. So subtracting 3x from 7x gives me 4x. Subtracting 3x here makes that a 0. And my last step is to divide by 4, and I'll have x is equal to 3. Some of you will do more than one step at a time, and that is okay, but again, it is all about the baby steps, and so sometimes putting those little things in will make it have a less likely of a chance for you to make mistakes. All right, so here we go is another problem, and this one has fractions. Some things to note is when we have an equation, we can get rid of our fractions. And we do that by clearing the fractions. And we can only do that if we have, like I said, equations. Okay. Another thing to note is I just want to notice or tell you guys, to remind you that a 3/4 x is the same as 3x over 4. So there's different ways to write them. You could think of that as 3/4 times x over 1. So that becomes a 3/4 x. So where we write things, you have to be a little bit careful. If that x were into the denominator, we would need to make sure to write it into that denominator. Okay, to clear fractions, what we are going to do is we're going to multiply the entire equation by that common denominator, that lowest common denominator, or the LCD. Our lowest common denominator in this problem is the number 12. So I'm going to multiply every piece, and I'm going to write this, and so I'm multiplying every piece by that 12. Okay, and then I'm going to clear the fraction because when I do this, multiply those, I'm going to do my reducing ahead of time. So that's going to turn into a 2. This is going to turn into a 4. That's going to turn into a 3. So I get 2x plus 8 equal to 9. x. And now subtracting 2x from both sides. And then dividing by 7. We get that x is 8/7. And yes, we can have fractions as answers. Not all the time do we get nice integer answers. Most of the time in here we will have ugly looking things. So just get used to them. All right, here's another one. Again, we just made a step up is all we've really done. And I want to remind you that this is nothing more than a bunch of fractions. So what we're going to do is we are going to clear the fraction. And to do that, we need that common denominator. So our common denominator, what we're going to have to do is factor this one so that we can find that common denominator. So two numbers that multiply together to give me a -2, add together to give me a -1. So I get this x minus 2, x plus 1. So my lowest common denominator is that x minus 2, x plus 1. All right, so I'm going to multiply everything by that x minus 2, x plus 1. I tend to write it this way for educational purposes. You do not need to write all these little steps out, but I'd like to do this so you can see it. And this is going to be multiplied by that x minus 2, x plus 1. Okay. Some people will multiply it and then have, I've seen it written this way. I've done this as well. X plus 1, x minus 2. And I'll have the whole fraction written out, or the whole equation. Okay. Whatever way makes it easier for you to understand. I like doing it this way when I'm teaching because then I can cancel things easily for us. So these two, and we can see kind of what's left. We have that x minus 2 times the 1 plus my x plus 1, and that's going to be equal to x plus 3. Combining my like terms, 2x minus 1. I am going to go over here. Subtracting 1 from both sides, or I should say adding 1 to both sides. And then subtracting x from both sides. I get that x is equal to 4. One thing to note when we do have our variable in the bottom or in the denominator, we do need to make sure that the answer we get does not make that denominator 0, because we cannot divide by 0. All right, here's one more. Again, we're going to clear our fraction. We're going to clear our fraction by multiplying by that common denominator. That lowest common denominator in this piece is that x minus 4. So I'm going to kind of leave out some of the extra steps. So I'm multiplying everything by that x minus 4. Nothing would cancel here. The x minus 4's would cancel, and I'd be left with that 5. Here, the x minus 4's would cancel, and I'm left with that x plus 1. If you want to continue and write that step in there, please make sure you do. And I'm going to distribute. Combine my like terms. I'm going to add 3 to both sides. And then I'm going to subtract x. So x is equal to 4. However, you will notice if I substitute 4 back in here, I get 4 minus 4 on the bottom, which is 0. This then must be thrown out, so we would have no solution. All right, hopefully you guys are doing okay. And we're going to do some power problems. When we have exponents, in this section all they do is have a single x. There's not like an x squared and an x, so it's just a single x squared. The idea is to, again, isolate that x piece. So I'm going to move the 5 over to both sides, or add 5 to both sides. And then I'm going to undo the squaring. So undoing a squaring is taking a square root. But when I take a square root, the thing to remember is that plus or minus. So don't forget. Okay, so we need to take the square root. And that's when we're taking square roots, or fourth roots for that matter too. Anytime we take an even root, we have to remember that plus or minus. Let's move on to x cubed plus 8 equal to 0. First thing I will do is isolate my x piece. So I'm going to subtract 8 from both sides. And then I'm going to undo the cube by taking a cube root. Now we don't do a plus or minus here because the cube root of a negative is the same as the cube root of a positive. We don't have, like we do in squaring something, if you square a negative it becomes positive. So like negative 2 squared is 4 and 2 squared is also 4. So when we undo it, we have to remember that plus or minus. Here we don't need to worry about that. So the cube root of a negative 8 is simply negative 2. All right, let's go and do one last problem. First thing I'm going to do is add 2 to both sides to kind of isolate that x term. I'm going to divide both sides by 5 again to isolate that x term. And now what we're going to have to do is undo the 2/3 power. Now remembering what 2/3 means, that means we're going to be taking, this is squared cube root. So to undo those, we're going to take a square root of something cubed. Since we're taking a square root, I have to remember the plus or minus. So 9 to that 3/2 power. Now since I'm taking a square root, the square root of 9 is 3. So this is going to be a plus or minus 3 cubed, which is either positive 27 or negative 27. So I get a plus or minus 27. So here were some basic equations. Again, most of them were linear unless they were these exponential pieces. But again, the exponential, here we just isolated that x term and then undid the exponent by understanding what the exponent is and then continued on. Until the next chapter.